Welcome everyone to the session where we are going to discuss how to solve the technical problem of propagating the context of a distributed transaction in situations where you are leveraging streaming technologies such as Kafka and Pulsar. So, as you may know, Elastic APM this year is all about solving problem, and the problem that we're going to solve it today is the usage of distributed tracing in architectures that are leveraging streaming technologies such as Kafka and Pulsar. For those of you that don't know me, my name is Ricardo Ferreira, and I'm a developer advocate at Elastic, where I'm part of the Elastic community that handles developer relations. Before Elastic, I used to work for other vendors such as Confluent, where I kind of got specialized in this world of streaming technologies, and before that, Oracle and Red Hat. If you want to discuss anything that has to do like observability or streaming systems and databases, feel free to reach out. That you can either get in touch with me by my blog here that is listed over here on the slide, or in the bottom of each line, you're going to see my Twitter handle that you can also use to get in contact. So let's take one step back and give ourselves a proper moment to discuss what distributed tracing actually means in this context and what is the value that you can leverage from it. So here's the thing. If you are responsible or you are part of a team responsible for keeping these systems up and running, you know that by the time things went south, you have to troubleshoot and find where the problem is, right? So it is your responsibility to find and use a lot of resources to identify the problem and making sure that the problem will never happen. So usually there are three main steps that you need to undergo. The first one is the suspicion, where you are going to perhaps using some metrics that you have in place to analyze if things are actually going good or not. From that suspicion, you are going to realize that there's a problem, and then you are going to start the investigation part that we usually call the drill down. After the drill down, which is, all right, I found where the problem is, you are going to the phase where you are effectively going to solve the problem. And by solving, I mean, if this is a software or code problem, you are going to create a patch for it and redeploy this in production to make sure that the business can continue. And you are going to take this time to actually learn from your mistakes and make sure that you are going to fix whatever problems might be related to the very fundamental problem that you've discovered. The reality is that those three phases, for each one of them, they take time, but the most time spent is in the drill down, where you are investigating where the problem is. It is a roughly estimate. Of course, this is more like a Ricardo estimate than anything else, but in my experience, that tends to comprehend like 60% of your time. That's a lot. It's more than the half of the entire time that when an incident happens, right? So the whole point of distributed tracing is to help those people that are willing to solve and fix the problem as soon as possible, because the reality is there is a huge gap between when the problem actually happens and when the problem is properly fixed. So distributed tracing creates this very natural and clear path for you to focus specifically on where the problem is, and keep that in mind that distributed tracing is not about solving the problems for you automatically, but it is about creating a clear path about where the problem is happening, right? So what I'm trying to say is that the usage of distributed tracing helps you with that 60% of the time that I've mentioned before. So if you think about in reducing that 60% of the time to something less and considerably less than this, it is a huge value that you and your team can start leveraging. And this is exactly what Elastic APM helps you to solve. It gives you this entire product with a very powerful architecture that allows you to implement distributed tracing using with proper support with all the technologies that developers are using these days, all their programming languages that are being used, and most importantly, to connect with the type of data sources that their applications needs to interact with. Now that you know the value of distributed tracing, let's understand about where this problem of streaming technologies comes into play, right? Streaming technologies, as you may know, is when you have a software architecture that one of the layers of this architecture has been implemented using a messaging or streaming technology such as Apache Kafka, Apache Pulsar, AWS Kinesis, Google PubSub, RabbitMQ, you name it. There's a lot of messaging and streaming technologies available out there. But by the time you have this building blocks in your architecture, you are going to end up with a very clear separation of concerns that you have clearly the persona of the producer and the persona of the consumer. In this example over here, which by the way, is a demo that I'm going to show in a minute for you, we have the Spring Boot application here that exposes a REST endpoint that is responsible for providing brand estimates for cars. For example, oh, I want to see how much a Ferrari costs. So you can call that API that exposed by Spring, and then you provide a brand, and then it return for you the estimate. The estimate itself is going to be retrieved by this data store, very well known, called Redis. That is a in-memory data store, and this is what the Spring Boot application is going to connect to retrieve the estimates. But as part of the same transaction, every time an estimate happens, the Spring Boot application is going to actually produce an event to a topic that has been implemented using Apache Pulsar. And why this event is generated? Because there is this downstream microservice written in Golang. We call those the analytics microservice that is going to perform some computations about how frequently certain brands are being estimated. For example, what is the count for how much a Toyota has been estimated today? So this microservice needs this information that's going to be pulled from an Apache Pulsar topic, and ultimately is going to be filled by the invocation into the Spring Boot application. So this is a typical end-to-end architecture that leverages a streaming technology. And if you are not sure about what is the actual problem that we're dealing here, the problem has to do with context propagation, right? So by the time you use technologies such as Spring Boot and REST and HTTP, everything is synchronous and occurs and likely in the same thread. So you don't have the separation of who writes the data and who reads the data, producers and consumers. So the context of the transaction can be automatically propagated from one layer to another. For example, you're going to see that in the demo that very effortlessly and actually transparently, the context will be propagated between the Spring Boot application into Redis. So those later will show up. But in Pulsar, this doesn't occur automatically because the context needs to be propagated between things that are executing in multiple layers and different threads, and likely in different containers or VMs. So you, as a developer, is responsible to actually write the code, or we should use the word to instrument your code in such a way that you are going to actually prepare the producer to effectively store the context into the message. The message got stored into the stream store, whether if it's Kafka or Pulsar, and then by the time the consumer pulled the messages from that stream store, you are going to be able to actually continue that transaction, which we use the terms like this is going to be a span continuation. So that span is going to continue into another layer, right? So in other words, you are not going to end up with, as depicted here, with a broken bridge, right? That is very fundamental for you to solve. That's a technical problem that you gotta solve, because distributed tracing is all about visibility, right? If the operators, if the team responsible for maintaining the applications are not being able to see the end-to-end of your transaction, they are not going to be able to very quickly to pinpoint where the problem is. And let's go back to the beginning, right? This is exactly what distributed tracing is all about. You should be able to provide ways for your teams to pinpoint very quickly where the problem is. So, in other words, this is what we want to achieve, right? In this diagram over here, this is a timeline for an Elastic APM showing that architecture that I've just described to you, the REST endpoint connecting to Redis, and also publishes a message to Pulsar. And then there is this microservice in written in Go that pull the message from Pulsar. So in this architecture, as you can see here, you have the line that represents the end-to-end transaction, which is this slash estimate over here. And then everything else happens within that span over there, including the send of the message to Pulsar and then the consumption of the message from Pulsar, which is the responsibility of the Golang microservice, right? So before we move forward, let me show you this demo already up and running, but without the fix, right? Without the solution that we are aiming to discuss it here. So I am going to show what we're talking about here, and what you are seeing here. I'm going to invoke this REST API here that, as you can see here, has been exposed over the port 8080. This is our Spring Boot application, right? And we are going to invoke this slash estimate URI. And then we're going to provide the brand here for, let's say, Ferrari. So if we invoke that API over here, you are going to see that here is the estimate, right? It runs request, and the estimate is going to be this 260,000, which is roughly how much a Ferrari costs. I don't know. But the important part, if we look to the Elastic APM piece, I currently have all the microservices properly instrumented, both the Java and Golang microservices instrumented using OpenTelemetry. I'm going to discuss OpenTelemetry in a second. And they're all sending their traces to Elastic APM as we speak. So there is this service over here called Brand Estimator, right? That if we look for the service map perspective, you're going to see, oh yeah, so I can see here that there's a Java application, which is our Spring Boot application that connects to Redis. So, all right. And then you're going to ask yourself, where's Pulsar in this picture? So suspicious number one. And then if you go back to the transactions, and if you inspect the transaction that named slash estimate, which is the REST and URI that I've just executed, we're going to be able to see, let me actually filter this for the last 5 minutes only. So we have a proper picture about the transaction that we're talking about. This one over here needs to be the estimate for the Ferrari. We're going to be able to see here the estimate for the Ferrari. And here we go. That's the Ferrari one. But notice, right, that there is the beginning of the transaction, the green part over here, and then there was the call to the controller, which connects to Redis to retrieve the estimate, and then the last mile of this transaction is this method called feed analytics that has been executed from the controller. Let me show real quick the code for this, and then you are going to understand the fundamental problem that we're talking here. So let's recap. This is what the operators are looking at. And for their perspective, they're going to see, yeah, I don't see anything regarding Pulsar over here. So how I'm going to be able to figure out that something happened after this or before this? And then the developer is going to say, wait a minute, but here on my code that I as a developer wrote, by the time you actually invoke the controller and the slash estimate, I make this invocation, this method called feed analytics, right? That the feed analytics method is going to use a producer from Pulsar to send the estimate to the Pulsar topic, right? And this producer has been creating, uses Spring Boot. This has been injected into this bean. But the point is, you can clearly see that this producer did not show up in the Elastic APM transaction. So this is the problem of visibility and broken context propagation. We're going to fix this problem in a minute. Before this, I need to discuss with you the concept of OpenTelemetry, right? Because as I mentioned before, we are using OpenTelemetry here. As I mentioned before, we are using in this demo OpenTelemetry to do the actual instrumentation. So the Spring Boot microservice is using the agent from OpenTelemetry to instrument the JVM, and all the traces from it are going to be sent to Elastic APM. But still, we have a problem to fix that has nothing to do with OpenTelemetry. But just to make sure that everybody is on the same page regarding how OpenTelemetry looks like and how it works, you need to understand that, first of all, OpenTelemetry, what it is a open source CNCF project that establishes how applications can collect telemetry data such as traces, metrics, and eventually there will be support for logs as well, but in a vendor neutral and using a common both protocol format and APIs. So this is a huge deal for you to start creating applications that produce telemetry data. And regardless of the backend that you are using, you can switch those backends and not necessarily need to refactor your code or change your code or impact your application. So let's say, for example, that you start your observability journey using distributed tracing using Jaeger as a backend. And for some reason, Jaeger is great, but you decided to switch Jaeger for Elastic APM because maybe you are interested on the awesome machine learning features that Elastic APM offers to you. The point is you can do this swap of the backend for your telemetry data without necessarily changing your code from your application. So OpenTelemetry is a huge win for developers that wants to ensure this vendor neutral portability. The other thing you have to understand about OpenTelemetry is that there are two ways for you to actually interact your application with the backend. The first one is directly, right? So what I mean by directly, if the backend supports the OpenTelemetry protocol, which we call OTLP, right? So the agent of the application can send those telemetry data directly to your backend, and there's no need for any mediation later. This is exactly what we're using here because Elastic APM supports natively the OpenTelemetry protocol. So there's no need for mediation layer. The other point, the other way for you to send from your application to the backend is using something called a collector. A collector is a mediation layer that is going to do exactly this. So the collector obviously supports the OpenTelemetry protocol and is able to receive those telemetry data from your applications, but the collector can do this talk natively to whatever protocol the backend supports and perform this communication. So there are pros and cons of using the collector. Obviously, the cons is going to be another distributed system that you have to maintain and keep and evolve. But if you are dealing with a backend that not necessarily supports the OpenTelemetry protocol, you're gonna need to use a collector. Hopefully, if you're using Elastic APM, you won't need this problem, right? With that said, as I mentioned before, Elastic APM supports natively OpenTelemetry, so you don't need a collector to send the data for it. The only thing you actually need to do, now we're talking specifically about OpenTelemetry. The only thing you actually need to do is to make sure your producer is going to insert the current context of your span of your distributed transaction into the what we call a carrier, right? In the context of streaming technologies, the carrier is going to ultimately be the message, or Kafka uses the word records. That's the term that they use to refer to these messages, right? It ultimately is the same thing, but this is a Kafka thing. They call it records. But you have to pick up the context, and you have to write code for this. It's not going to be very complex code, but you have to write code to put this context into the message. And then in the receiver side, which is the consumer, you also going to need to write some piece of code to extract the context from the message or record if you're working with Kafka and continue the transaction, right? So I brought you here some snippet codes that aims to showcase this, but I'm actually going to fix this problem here in the code for you right now so you can see it actually running. So let's go back to the demo where I will fix the problem. I'm going to explain the code, and then we're going to see how this is going to look like on Elastic APM after the fix takes place, right? This producer that I'm using here has been created by, as I mentioned before, this is a Spring Boot application. So I have this bean Spring Boot called Pulsar configuration. So as you can see here, I've annotated this bean as a Pulsar configuration, So the first thing that this bean does is to create a Pulsar client. So it's going to instantiate this client. This is the topic that is going to use. And then, as I mentioned before, this is macro as a bean. So the URL will be provided by the by a environment variable via parameter, right? And then after creating the client, the producer will be created from that client. And here's the interesting part. After specifying the actual topic that's going to be used, you can't associate. This is part of the Pulsar API, the client API for Java, right? You can associate what we call an interceptor, right? So I mentioned in the beginning of the presentation that we aim to solve the problem in a more generic and reusable way. And this is my advice for you. Try to implement this whole tracing, fixing, and context propagation using the concept of interceptors if your messaging or streaming technology supports, which is the case for Kafka and Pulsar, right? So in my case over here, I created this interceptor. I'm going to just enable it. I'm going to stop actually the execution of the Spring Boot for a moment. And let me show real quick what this interceptor does. So the interceptor is a Java class that implements the interface called producer interceptor. And the method that you have to actually, the callback that you have to implement is called before send. That, as the name implies, is going to be executed before you actually transmit the message into the broker. So what we are doing here is we are creating a new span programmatically using everything is from the OpenTelemetry application. There's nothing Elastic APM specifically. So this is a vendor neutral code that you are going to write. You are actually creating a span and you are decorating the span with some annotations or labels, right? But the important part is that we are storing the context, this is the context, into the carrier, which is the method. So let me show real quick what this method does. So as you can see here, the method is we are retrieving this text map propagators from the global context for an OpenTelemetry, and then we are injecting the context, which is the actual context we want to propagate, the message, and a setter. And what is the setter? The setter is this callback implementation that I've wrote here that has only one callback method that you need to worry about. It's called set. It's very intuitive. So here's how your brain needs to work. Here's the context, here's the carrier. How I put the context into the carrier, right? So this is logic you are going to implement here on this method called set, right? So this is exactly what I did here. So all this code essentially puts the context into this entity called properties that is part of the Pulsar API configuration. So this is essentially what you need to do. So I've enabled this interceptor already on my configuration. I did, yeah. So let me execute one more time my brand estimator. So I have a script here called run brand estimator, which essentially is going to boot up my Spring Boot application one more time. So as you can see here, it forces creation of a Maven build. So you can compile the code from scratch. It's going to boot the Spring Boot application. And at this point, it should be up and running. Before I forget, all this code that you were looking at here is going to be made available for you in the resources section of this presentation. And I personally going to provide it here in the chat in a minute, right? But if you want to play with this code, go to my GitHub repository and everything will be there. So you can inspect and reuse the code as you wish, right? So the code is up and running. So let's do another estimate for a Ferrari one more time to see if this is actually going to solve the problem. So I'm going to send it. And it went through successfully. So let's see now how this new transaction looks like. First of all, for the service math perspective, we should have in a second a new transaction coming in. And then if we look for the timeline perspective, let's see when the new transaction comes in. It didn't went through so far. So let's wait a couple seconds. All right. Okay. Let's perform some more invocations. Here we go. All right. So we are now seeing the estimates being shown over here, which is good. Now let's just bounce our microservice written in Go that all the code is already there, because for some reason we've stopped the analytics. And then let's start one more time. Okay, so the analytics is there. oh, I might have some different instances of the analytics already up and running, which is not good. But if we see the code over here, we should see that, all right, there's the other transactions. Let's check this one over here. So as you can see here, the new code is already reflecting the changes that we made. But the point is, the flow is being completely at this point. So the microservice, in a moment will show up because we bounced the microservice, the analytics, and we start belonging to this transaction over here. Let's wrap up right now. So hopefully you understood the solution that we've used here. So here's the code I'm going to provide in a minute. And lastly, let me just say that if you are working with Java, the OpenTelemetry already has support for Apache Kafka, so you don't have to worry about this unless you were using another programming language that's not Kafka, that's not Java. Then the very same solution that we use it here using interceptors and the SDK, you're probably going to need to write into another programming language that's not Java if you are using Kafka, right? If you're using Kafka with Java, the OpenTelemetry project already provides support for it. With that said, I would like to thank you for your time you spent here with us today, and I wish good luck for you and enjoy the rest of the conference, and feel free to reach out if you have any questions. Thank you.